everyone, and welcome to this video going over the lesson 18.3, Triangle Proportionality Criteria. Let's get started. On the right here we have triangle SAT and line MR going through it, and it says if line MR is parallel to line ST, so remember this symbol means parallel, explain why triangle MAR, so MAR is this top triangle, is similar to triangle SAT, which is the entire thing. Well, remember our three similarity criteria are SSS, SAS, and AA. Now, because my triangles don't have any side lengths on them, we can't possibly check for SSS or SAS. So it looks like we're down to AA. And because my two lines right here are parallel, we have to remember that parallel lines come with angle relationships. And so angle M is going to be congruent to angle S because those are corresponding angles. Same thing with angle R and angle T. Those are also congruent because they're corresponding angles. And with that, we have our two congruent angles. So these triangles are similar by AA. Now that I know the triangles are similar, I know that their corresponding sides are proportional. So I'd like to complete this proportion, but before I do that, I'm going to draw the two triangles separated so that I have an easier time visualizing them. So I have that top triangle, MAR, and then I have the entire triangle, which is triangle SAT. So my proportion is AM, which corresponds to AS. Those are both the left-hand side. And then they want to compare AR, which must line up with AT. So this question mark is going to be AT. And now they want me to fill in my measurements. So I'm going to label my first picture. AM equals 12 centimeters. MS equals 9 centimeters. And AR is 15 centimeters. And I'm going to label RTX because we don't know what RT is. So if I'm going to fill in this proportion they want me to set up, AM over AS equals AR over AT. I know that AM is 12. And in order to find AS, I'm going to have to add the 12 and the 9 together. Because in order to find AS, I need that entire length, which means I have to add those two parts. So 12 plus 9 will get me that AS is 21. AR I know is 15. And similar to how we had to add 12 plus 9 to find AS, I need to add 15 and X to find AT. And what that will look like, since we don't know what X is 15 plus X. And now that my proportion is set up, I am ready to cross multiply. 21 times 15 is 315. And remember, when we multiply a number times an expression, we have to distribute. 12 times 15 is 180. And 12 times X is 12X. I'm going to subtract 180 to each side, leaving me with 135 equals 12x. And if I divide by 12, I know that RT is going to be 11.25 centimeters. Now, I had to add the lengths of AM and MS to find the entire side length of the big triangle. What I'm going to show you now is that there may be a shortcut. The triangle proportionality theorem says that if a line is parallel to one side of a triangle, then that line splits the two other sides proportionally. What that means is, notice how I drew a line parallel to one side of the triangle. I can say that B over A equals C over D. This parallel line splits the other two sides of the triangle proportionally. So I can make a proportion where I compare B over A, and it will equal C over D. In our example up here, that means I could have done 12 over 9 equals 15 over x, instead of having to add 12 and 9 and 15 and x like we did before. If I were to cross multiply now, I would get 12x equals 135, and x is still 11.25. So, if we know that this line is parallel to the third side of the triangle, we can set up our proportion as so. And a way I like to remember it is by saying top over bottom. So the top measurement over the bottom measurement equals top over bottom on the other side. So let's try this. Clarissa needs to find the distance across the lake shown. The known measurements are shown. What is the distance dA? So notice how I have a line parallel to one side of the triangle, which means I can set up the proportion top over bottom equals top over bottom. So the top measurement, 27.5, over the bottom measurement, 54, equals the top measurement on the other side, 29, over the bottom measurement, x on that side. And now I'm ready to cross multiply. 27.5x equals 54 times 29 is 1,566. And if I divide by 27.5, I get that x is equal to 56.9 kilometers. That was a lot quicker than how we did the first problem with adding the two measurements together. So if you notice that there's a line parallel to your third side of the triangle, set up the proportion top over bottom equals top over bottom. Now, if you think back to one of our first chapters in first semester, we talked about converse to conditional statements. To write the converse of a conditional statement, you flip the order. So originally we said if a line is parallel to one side of a triangle, then we have proportional parts. So to flip the order, the converse would be if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if I were to draw a picture with line L and extended side M, and if I checked the proportional parts, and if my ratios were the same, so if this is true, then line L must be parallel to line M. And that is true, because if those parts are proportional, that means we have similar triangles, which would mean these angles are congruent. And in order for corresponding angles to be congruent, that would mean the lines are parallel. So keep an eye out for that. If you notice that the sides of a triangle are proportional, you can therefore say that the two lines are parallel. Let's try one more example together. given line RE is parallel to line AT, which is parallel to line IO, which is parallel to line NS, determine each length. Now by the transitive property, all of these parallel lines are parallel to one another, which means we can use our triangle proportionality theorem. To find ET, I'm going to label ETX. I'm going to set up my top over bottom equals top over bottom. So on the side closest to you, we have 48 over x, and I can set that equal to 36 over 24. Top over bottom equals top over bottom. And if you were to cross multiply and solve, you would get that x is equal to 32 centimeters. Let's try another one. Now I'm supposed to find AI. I'm going to call it AIY. Now notice that AI is a little further down. If I want to set up my proportion top over bottom equals top over bottom, I don't have to use the highest measurements. I could use 24 and 32, now that I know that ET is 32. So to find AI, I can say 32 over 40 equals, I need to make sure that everything lines up. So do we see how 32 and 24 line up with one another? So 32 over 40 equals 24 over y. And if I were to cross multiply and solve, I would get that y equals 30 centimeters. And last one, AT. Notice how AT is one of the sides that is parallel. AT is not on one of the sides that's being split by the parallel lines. It is a parallel line. So in order to solve for AT, I have to go back to the original method that we were solving these problems. I'm going to draw the two triangles separated. So I can say triangle ECR, and the bigger triangle that includes AT and C. I know that EC is 48 centimeters and CR is 36 centimeters and ER is 27 centimeters. And I'm looking for AT, I'm going to call that Z. And look, in order to find the side length CT, I once again have to add those two sections together. So 48 plus 32 will be 80 centimeters. And to find CA, I have to add 36 and 24, which would get me 60 centimeters. So now that I have my two similar triangles and their side lengths filled in, I am ready to set up my proportion. Z corresponds to the 27 on the other triangle. And remember, to set up a proportion, you need one ratio that's fully completed. So I could either use 80 over 48 or 60 over 36. Either one is fully completed and either one would work. I think I'm going to go ahead and go with the 80 over 48. And if I cross multiply and solve, I would get that Z is 45 centimeters. So, one piece of information before I go. I've been saying top over bottom equals top over bottom, but you don't always have to set up your proportion that way. The way I see it, we have three measurements for each side. We have the top measurement, the bottom measurement, and the whole measurement if we added the two together. Any combination works as long as your proportion is consistent. You could do top over bottom equals top over bottom. You could do bottom over the whole thing equals bottom over the whole thing. You could do whole thing over the top. You could do bottom over top. As long as everything is lined up and consistent, there are lots of different combinations because all of the sides are proportional. There's lots of different ways that you can set the proportion up. So take that into consideration because sometimes you're not always given the top and the bottom measurement. Sometimes you'll have to use the whole measurement, which means your proportion might look a little different. Please let me know if you have any questions, and I'll see you in class.